A faint breath echoing inside a helmet. Out of the darkness, stars slowly fade into view. The International Space Station, a beacon of human ingenuity, floats silently for 100 kilometers above the Earth. It glides over the night side of our world, a river of city lights tracing the continents below. For the astronauts aboard, this incredible outpost is home. It's a place where Earth looks close enough to touch, yet remains impossibly, tantalizingly far away. But what if something went wrong? What if, during a spacewalk, you accidentally fell from the ISS? Imagine a gentle push, a small mistake, and suddenly you're drifting away from the safety of the station. Here's the first shocking truth you need to understand. You wouldn't fall at all. Not in the way you think. You wouldn't plummet straight down to Earth like a stone. Instead, you would just float there, watching the colossal space station move alongside you, both of you racing around the planet together. Why? Because the ISS is already falling. Earth's gravity is still surprisingly strong up here, about 90% as powerful it is on the ground. Gravity is constantly pulling the station and everything in it toward the center of the planet. But the station is also moving forward at an incredible speed, over 27,000 kilometers per hour. It moves so fast that as it falls toward Earth, the planet's surface curves away beneath it at the exact same rate. This state of continuous, unending freefall is what we call orbit. So if you pushed away from the station, even gently, you'd simply enter a slightly different orbit. You would start to drift, slowly at first. The distance between you and the station would grow, second by second, meter by meter. The familiar structure of the ISS would shrink, becoming a distant star against the blackness. Out here, there is no air to create drag and slow you down. There is no ground to stop your movement. There is nothing. Space does not forgive small mistakes. Without a tether connecting you to the station, and without a propulsion system like a jetpack to push you back, you would drift forever. You'd become your own tiny satellite, a lonely monument to a single misstep, orbiting the Earth for potentially centuries. Imagine the perspective. You'd be spinning slowly, a silent witness to the majestic dance of day and night sweeping across the globe below. You'd see sunrises and sunsets every 90 minutes, a breathtaking spectacle of color erupting over the curve of the Earth. But it would be a beauty tinged with absolute isolation. Of course, this assumes you're safe inside your spacesuit. What if the suit itself was breached? Space is not completely empty, but it is a near-perfect vacuum. There is no breathable oxygen. There is no air pressure. There is no medium to carry sound. If your suit failed, the first thing you'd notice would be the sudden, deafening silence. Even the sound of your own heartbeat would fade away. Unconsciousness would come in about 15 seconds, not from the cold, but from the simple, brutal lack of oxygen to your brain. It would be a silent and perhaps strangely peaceful end. But let's return to our original scenario. You're drifting safe in your suit but lost. What happens next? Your orbit, slightly different from the ISS, might not be perfectly stable. Over time, tiny gravitational influences and the faint drag from the wispiest outer layers of the atmosphere could cause your orbit to decay. Earth's gravity would finally start to win the battle, pulling you closer. But again, you would not fall straight down. Your path would be a spiral, an ever-tightening coil around the planet. You would circle the Earth faster and faster as you descended, your orbital speed increasing dramatically. At about 120 kilometers above the surface, you would hit the first noticeable traces of the atmosphere. The air returns, but it wouldn't be a gentle welcome. At your immense speed, the sparse air molecules would feel like hitting a solid wall. The atmosphere becomes a wall of fire. This intense heat isn't because space is hot. It is because the air in front of you is being compressed so violently and so quickly that it has nowhere to go. This extreme compression generates incredible temperatures, well over 1,000 degrees Celsius. Friction turns your colossal speed into overwhelming heat. A brilliant plasma sheath would envelop you. This is precisely why spacecraft like the Soyuz or Dragon capsules are equipped with heavy, Ablative heat shields. These shields are designed to absorb and shed that thermal energy, burning away layer by layer to protect the astronauts inside. A human body, even inside a spacesuit, does not have a heat shield. The result would be swift and final. This scenario is, of course, a nightmare. But it is a nightmare that NASA and other space agencies have planned for since the very first spacewalk. In reality, an astronaut is never untethered. They are always attached to the station with multiple, redundant safety tethers. They are trained relentlessly for every possible contingency. They have emergency propulsion systems, like the safer jetpack, designed to fly them back to safety if they ever became detached. Every single spacewalk is built on layers and layers of safety protocols. When we see the ISS gliding through the sky, it's easy to think it's defying gravity, but it isn't. It's dancing with it. Orbit is a delicate balance, a fragile harmony between the constant pull of falling and the momentum of moving fast enough to always miss the ground. The very same physical laws that could create such a terrifying scenario are the same laws that keep our astronauts flying safely above us. From their vantage point, borders disappear, conflicts seem distant and petty. They see one planet, one interconnected system, one home. And perhaps the greatest lesson from imagining what it is like to be lost in space is realizing just how precious it is to stay in orbit, together, on this beautiful blue marble. Thanks for watching. If you found this journey thought-provoking, consider subscribing for more explorations into the wonders and challenges of our universe.